Good morning, guys. So yesterday I asked you this question of how do you know that the Earth is round? So many of you answered that, yeah, obviously you can look at the pictures and or you can in the internet and you can see that, yeah, the Earth is round, right? So, but to take the pictures, you need a lot of technology. You need to send machines into the space. You need satellite images. So, but if you don't have this technology, how would some person know that Earth is round? People knew that Earth is round many years back. So I'm going to tell you a story of a mathematician, Eratosthenes. This was in 200 BC, okay? This was like 2000 years back. He actually knew that Earth is round, and in fact, he computed the circumference of the Earth. Okay, so that's the story of this mathematician who did this. So it begins like this. So he knew about a place in Egypt called Surya, and what he knows about the place is that at a certain point of the year and at a certain point of the day, there was no shadow of certain objects. So that means that the sun rays are falling overhead, vertically, right? There are no shadows, that means that the sun rays are falling vertically. So this was a different place, not at the place he was from. So he was thinking what's happening at his own place, right? It was at a different place. He read about that place, but he wants to know what's happening at the same place he lives in. So he tried to observe that at the same day and same time. So if Earth was flat, then it should have happened that the rays would also be vertical at this place, Alexandria, the place he is from, and there would not have been any shadows, right? If Earth was flat, like at this, you should see the same thing at that place and at this place. But what he really observed, to his surprise, is that there were shadows at this place at the same time and day. So in fact, he observed that the shadow is at an angle. He was getting shadows from rays which are at an angle of 7.2 degrees. Okay, so he got shadows at the same time of the day. So how do you explain this? At some place on the Earth, at the same time and day, you have some angle, and some other place you have some other different angle. So he explained that by saying that Earth is actually curved, so it's round. So if you take this is Surya and this is Alexandria, so the sun rays are falling vertically. Okay, so there's a vertical rays at Surya, so they're falling overhead. But the same vertical rays would make an angle, some different angle at Alexandria. Okay, so he says that they're making an angle of 7.2 degrees at Alexandria, and that's because the surface of the Earth is curved. Okay, here it's vertical, but as you move here, these vertical rays will make an angle of 7.2 degrees. Okay, so that was his explanation for why the Earth is round. Okay, by using this idea, he explained that the Earth is round. Okay, so that's really nice. Not only that, he actually estimated the circumference of Earth. Okay, so this angle between these two lines is 7.2 degrees. So we can see that this other angle, this angle is also 7.2 degrees. Okay, so we know that this portion, the distance between these two cities or these places was 800 kilometers. So he asked someone to measure the distance, and it was 800 kilometers. And so 800 kilometers is corresponding to this angle of 7.2, right? So 7.2 degree angle corresponds to 800 kilometers. So you want to know what was the total circumference. The circumference will correspond to this angle of 360, right? The total angle. Okay, so the 360 angle should give you some distance. So what is the distance? You just compute. So the 800 over 7.2 times 360, it turns out to be 40,000. Okay, so that is his estimate of the circumference of the Earth, and in fact, this is quite accurate. The actual answer is somewhere around 3,941 kilometers. Okay, so with this simple idea, a simple kind of basic thinking about how the rays are falling and shadows, you could estimate the circumference of the Earth. It's a mind-blowing idea.